Everyone, my name is Nico Kabar. I'm a solution architect at Tigera, and today we'll be talking about all things around securing and troubleshooting your microservices on GKE with Calco Enterprise. They'll be focused on network policies, especially with Calco and Calco Enterprise. We'll look into some use cases, some of the challenges that a lot of our users are seeing, and we'll also do a demo. Just as a reminder that those sessions are recorded, so if you miss anything or you want to share it with your team, there will be a link will be sent, including the slides and the recording, shortly after this session is over. Try to make it as interactive as possible. So, there is a Q&A box that you see. Feel free to chime in there with some questions, and we'll be able to answer them towards the end. And if we have more time towards the end, you can kind of share your, speak up and talk about it, and talk, raise your questions directly to me. So with that being said, let's get started. So as I mentioned, kind of from today's agenda, we'll be doing a quick overview for Calco and Calco Enterprise. If you don't know much about it, this is a good, quick overview for that. Before we jump into network policies on GKE, I would like to kind of talk about just overall, what are some of the options in terms of just network design consideration, including both networking and policy when it comes to running GKE. We'll focus on kind of two main use cases around, security groups, kind of tightening your enterprise security measures on GKE with Calco Enterprise, as well as some troubleshooting scenarios as well. And we'll showcase that in a demo. So that way it kind of solidifies your understanding of the topic here. So before we get going with the GKE specific topics, I wanted to kind of do a refresher in terms of what is Project Calico and why you should care. So Project Calico is a community-driven open source project that was started around the same time Kubernetes did start, to provide kind of an open source networking framework for both kind of connecting pods and securing pods using network policies. We've extended since then to not only just secure containers and pods, but also virtual machines and host-based workloads. So at the high level, why you should care, and why Calco has been widely adopted today by users. It is blazing fast in terms of its performance. Again, as a hard requirement for any CNI is going to provide a unnetted, network connectivity between the pods. So Calico uses a very, tradition has been using layer 3 networks where you can have some encapsulation or unencapsulated approaches. Either way, utilizing native Linux data plane capabilities. It is uniquely simple architecturally so that it can actually scale. So that presents a kind of second factor here is around how massively scalable you can run your workloads with Calco. Because it's kind of built onto the routing protocol of the internet, that is BGP, you can scale the number of nodes basically up to the number, and the number of pods basically up to the number of Kubernetes. Kubernetes nodes and scale numbers. In terms of industry standards, there's a lot of lots of solutions have adopted Calco out of the box today, including AWS, EKS, Google's GKE, Azure AKS, and IBM IKS, all of which have picked Calco to be the default network policy enforcer, as well as some of the on-prem or kind of hybrid cloud solutions like Red Hat, Mirantis, and Rancher have all either included Calico or integrated with Calico as an out-of-box solution for securing and connecting pods. We're also aware of more than 150,000 known clusters out there that are using Calco today. Relying Calco with hundreds of thousands of nodes and millions of workloads. So we're trusted by a lot of the real-world kind of production use cases today. In terms of Tigera, the company behind Calco, so we invented and maintain Project Calico today, and we also help with co-leading a lot of the Istio upstream, specifically the security working group of Istio. And not only that, we have a enterprise version of Calico called Calco Enterprise that is trusted by top global enterprises. You can see here some of those names, a lot of financials on big kind of Fortune 100 and 500 companies who are trusting us with their workloads and to secure their workloads and help them move to either microservices or cloud, all while protecting their business critical applications. So let's switch kind of, that was kind of a good refresh, quick refresh of what Calco and Calco Enterprise are. Let's talk about GKE networking options. I mean, probably many of you are either interested in working with GKE or using it today. And GKE has a pretty solid set of options in terms of networking and policy. So out of the box, let's talk about networking first. So there's two key mechanisms or approaches for networking, and when you launch pods into GKE, one is you can tie it to your VPC, so it's kind of more VPC native, and the other is not. Basically, it's you don't have that integration into your VPC routing and subnetting and so forth. So the default is to kind of enable the VPC integration. And that way you have when you create subnets and in your network, and so, when you create subnets, you can actually use those to hand those pods running on GKE IPs from those subnets, and therefore they are pods are just treated like any other VM that is running on your network. The other option, as I mentioned, is if you don't want that, which is kind of what says here, the Kubernetes option. It's not recommended because it's not really tied. You're not really tied to the VPC. So you also have the option of using the Calico for policy. So sorry, for networking, you have two options: Kubernetes and the ordering should be changed here. For networking, you have Kubernetes out of the box, and then GCP NetD, which is basically integrated with the native VPC integration that it provides. And in terms of policy, which is another kind of thing you kind of have to look into, is if you want to enable current network policies to be enforced, you have to enable network policies when you launch the cluster. And when you do that, GKE automatically manages Calico for you. So it creates and kind of deploys open source Calico for policy, and manages kind of the lifecycle of Calico when it's in that setting. Finally, if you want to use something like Calco Enterprise, which we'll talk about, which is kind of unmanaged network policy, you have to make sure that you're not launching your GKE with network policy, because the idea here is that when you are using Calco Enterprise, you want it as a solution to manage Calico for policy enforcement. You don't want GKE as a management plane to manage it. So therefore, you have to kind of watch out for that option when you launch it. Finally, there's an option for enabling intranode visibility. This is an option to ensure that other GCP services like logging and monitoring and Stackdriver and overall like routing and rules apply to pods if you're using the GCP NetD. So you want to make sure that you enable it if you want that kind of visibility and integration into native GCP services. So this is kind of a quick summary of what options you have there. Let's talk about network policies on GKE. So as I said, out of the box, when you enable you kind of have two options if you want to use network policies, and we'll kind of describe network policies and their value in a bit. But one is using open source Calico out of the box, which is enabled for you once you have that enable network policy command when you launch GKE, or when you launch it from the console. There's an option for you there, and what that would do is launch, as I said, launch Calco for you, and you can just run deploy network policies, and that's done for you. Now, the other option is if you want to use Calco Enterprise. There's a superset of functionalities that we'll be discussing today, and that kind of goes back, beyond what the basic network policies that you have with that out-of-the-box option that I talked to you about. So if you're not too familiar with network policies, let's kind of do a quick refresh on why you should care about them and how they're important for your workloads. So at the high level, the Kubernetes networks, the network model is a flat network model. That means that by design, pods on each worker nodes, or on nodes, have to communicate with all the pods without any NAT. So any CNI to be conformant has to provide that functionality. IPs are dynamically assigned to workloads, and they're ephemeral, and they're not deterministic. That's also kind of another key thing to remember around overall network design when it comes to Kubernetes. Finally, there could be an option where you have non-routable IPs. So in the case of Kubernetes, if you do that by default, then it's not going to be routable. But if you have, if you're using GCP CNI, the GCP NetD that I described earlier, then therefore by definition you're using a block of IPs that are routable within your VPC, similar to any other VM. But if you do, if you're on-prem, or you have, you're deploying Calico, or sorry, you're deploying Kubernetes on IaaS, for example, you have an option of doing non-routable IPs. So everything, all the IPs are kind of not routable within your environment, within your VPC, and therefore there could be some additional challenges around that, because you don't know really outside of the cluster, the IPs are not relevant. So this is where kind of the main drivers behind Kubernetes network policies. What they do is allow admins or app developers to define their network rules using same deployment artifacts. So similar, you can create YAMLs to define. You can write the YAMLs to define how your application should, how the network of the application should be kind of behave. What are the rules that define the direction of the traffic and ports and so forth. There are three key attributes to or characteristics of network policies. Of course, they have to be label based, similar to a lot of things in Kubernetes. You label your pods or deployments with a key value of pairs. You use policies to apply those, to use selectors to apply those to those resources. Of course, it has to be declarative, similar to a lot of things in Kubernetes. You define what the end state of the policy should look like, and you use kubectl or whatnot to apply that. And finally, it has to be, of course, dynamic. You're not going to be in the business of manually making sure that certain pods have certain policies applied to them. You just expect the system to be dynamic in nature and use those labels to dynamically update the policies as pods are removed or respawn or whatnot. So if we do, I'm not going to read all these because there's a lot of things around Kubernetes network policies, but just a few things that I want to kind of highlight. As I mentioned, they're really helpful to define kind of the security posture of your application from a networking perspective. Definitely highly recommend to look into using them if you haven't, especially if you have a lot of applications running in the same cluster where there's multiple teams or projects or namespaces, and that way you can ensure that the traffic for your application is protected. They can be applied, just a reminder that the policies are enforced by the CNI. So although there is a Kubernetes network policy within the Kubernetes API, but it doesn't really enforce those policies. It just accepts that the policy's definition and stores it in etcd, and then the CNI is responsible for translating that into policy rules and programming that in each of those Kubernetes nodes. You can apply the policies, on namespaces, on the pods, using selectors, or even IP siders in both ingress and egress directions. And just to note that, similar to a lot of things in Google, firewall rules are, there's an implicit deny, so there's a default deny that is expected. But as I said initially, out of the box, when you launch GKE, all pods can talk to each other. But the moment that you apply any policy on any pod, there's a default deny there. So unless you explicitly call out as a rule what to allow, it's going to be denied. So just a quick, simple example here for a network policy, if you haven't seen any before. As you can see here, this is kind of the YAML file on the left-hand side. And what we're doing here, we have three services with front-end, helper, and DB in the namespace called my namespace. And what we're trying to do is ensure that only connections coming from front-end on port 6379 are allowed to connect to the DB pods, and nothing else should be kind of allowed. So you can see here that we're describing the namespace, we're describing the where this should be applied, the role equals DB pods, and we're allowing the traffic in the ingress direction coming from the front end service on port 6379. Note here, please, please note here that there is we didn't specify a deny rule for this type of traffic coming from a different pod, but the moment that we apply this rule here on those pods, automatically will deny all the traffic unless it matches one of those rules. So keep that in mind. So let's kind of switch over to what can Calico Enterprise do here for you. As I mentioned, out of the box, you can run GKE and enable network policies. It's going to run Calco open source in network in policy enforcement mode, and you can do a lot of things with Kubernetes network policies. You can use them. The challenge starts where you have different kind of enterprise level requirements where there's some some RBAC requirements, alerting, overall management, tighten security, and some kind of, I would say, more advanced functionality that you need. This is where kind of Calico Enterprise can come in and can work seamlessly with GKE to kind of solve those enterprise problems. So just a quick note here that, similar to many others kind of Kubernetes solutions, Calico can run, Calico Enterprise can run on pretty much wherever Kubernetes can run and beyond. So whether you're running across multiple managed Kubernetes services or on-prem or upstream Kubernetes, a good way that you can have a common way to define your network and network policies for your Kubernetes workloads is to use Calco Enterprise, regardless if you're using a hybrid of solutions, Kubernetes solutions, whether they're managed or unmanaged. So the core capabilities that we focus on for the enterprise are around security controls, access controls, and visibility and troubleshooting. So what that means is focusing on helping you implement security controls beyond just defining an allowed rule and a security policy. This is going to help you with meeting your enterprise requirements from the compliance and reporting as well. Access control, in a sense, to make sure that pods, you have a way to do fine-grained access controls for external services. So if you have certain pods that need to talk to certain VPC services or public services or even on-prem services, you have a way to fine-grain how you define this policy, and that way you are not kind of leaving it, open for all pods to communicate to those services from a network layer security perspective. Finally, key core capabilities are around visibility and troubleshooting, having full visibility into what's going on within your network, how you can see high basically detailed logs and detailed data around your network flows can be very critical to root cause analysis, and if you're doing any active troubleshooting, to address those issues rapidly. So if we look at kind of the first challenge, usually like, let's say, hey, you're using GKE today, and you're deploying some applications, and you have certain requirements around how you kind of segment or zone those applications. Of course, you can definitely start if you have very simplistic, requirement that probably just a Calico with, open source Calco with that comes out of the box with GKE can serve you well here. But if you have any certain requirements for what I mentioned earlier around more advanced capability, like if you have, if you are kind of networks, you and your network security teams need certain visibility levels for those policies, need some reporting, audit logs. This is where this challenge is kind of highlighted. So one way also to address this is what we call tiered security policies, where we provide a mechanism for the network admins, security admins, or even just platform admins to highlight higher precedence policies that apply to all the namespaces and all the pods, or selectively on some pods and namespaces. So, an example of that would be if you have certain level of requirements that need to be met from a compliance perspective, from an auditing perspective. You want to make sure that, regardless of the application that's running, regardless of who's using this Kubernetes cluster, you have this policy enforced. Therefore, you can actually have that in a higher tier, and that policy will be evaluated and enforced before your application level policy kicks in. And that's kind of critical to have that level of hierarchy there, so that you can differentiate between critical policies that are applied cluster-wide versus policies that are required or created by application for a specific namespace. Another thing that is really helpful here for you as you move your workloads into GKE is to have full-end and be able to see those policies, visualize the policies, understand what's going on. One thing I found it like very, very not user-friendly is like how you can actually, like out of the box today, you can create policies, you can probably figure out a way to configure RBAC for various teams to create their own policies, but then what? Like, then you start saying like, okay, how many policies do I have running? What is each policy doing? Are there any policies that are kind of impacting other policies or conflicting with other policies? So getting that kind of overall management dashboard to just understand what's going on is a critical first step. So this is something that Calco Enterprise can do for you out of the box. Second thing is, as I mentioned, kind of compliance reporting. We can manage to run reports and make sure that your endpoints, pods, basically, and namespaces are protected. They have the right set of policies applied to them. There is, also from a CIS benchmarking, you're doing well, and it's kind of in a healthy position to say you're basing your security posture based on CS recommended benchmark rules. So all that becomes, when it's automated for you, it's a lot easier for you to consume those reports and also use them to ensure that you're doing and you're securing your workloads and your cluster. Next are like around audit logs, everything around creating policies and making any basically API or UI changes is audited, so you can keep track of all things related to the policy creation. This is something that is critical, as I said, if you have multiple teams working. Actually, a lot of users are kind of afraid to use network policies because, one, they don't know what their impact is to their workloads. I mean, they see the value of using network policies, but they're not sure if the risk of pushing a policy that is gonna mess up their cluster or their application is worth the reward of using network policies. And second is around just being able to kind of audit all those interactions for creating policies and so forth. So Calco Enterprise can address those two issues there. Let's switch kind of into visibility and troubleshooting before we do a demo. So as you know, because of the dynamic nature of Kubernetes, if you're deploying your application, or, especially if it's done by a CI or CD systems for kind of ongoing and continuous development of your application, continuous release, you feel like you're kind of flying blind with Kubernetes because there's typically you assume that the network is there and it's supposed to be doing what it's supposed to be doing, or doing what it's supposed to be doing in terms of connecting your pods. But there are some issues that sometimes you can't detect just until you see them at the application layer, and that's where we can come in and help kind of detect, alert around issues that can really help you avoid downtime and avoid long hours of troubleshooting. So, the first way we do this is how we capture the traffic logs. Typically, if you're coming from a network or NetSec background, of course, you have to kind of look at logs of the traffic to understand what's going on, and whether you're doing an active troubleshooting or analysis, or you're kind of looking back to address something happened in the past. So typically, there's a 5-tuple traditional flow log that you're capturing, source and destination, IP and port, and of course the protocol. But that's not really enough with Kubernetes, because you have a whole lot more context that you need to have in order to even relate this traffic flow to an application or a flow or connection. So it's really critical for us to kind of get more than just your typical, more than your typical 5-tuple data. We collect things like the namespace, the source pod, destination pod, destination namespace, any labels, and so forth. So you have more context around that data. Next, what we do is, of course, you have that those logs. You can actually use them in your existing logging solution. If you're using Alex, Splunk, whatnot, you can analyze them, or any SIEM solution that you're using. But if you just want to use those logs to visualize what's going on in your environment, this is a great way to do it. You can interact with this flow visualizer and drill down into your network flows, filter through the namespaces. You can use RBAC to ensure that only select groups can access only their namespace. But you have a full visibility on what's going on at each of the layers for your services, deployments, and pods, and how they're communicating, and so forth. Another key thing to remember here is that if you're trying to create network policies or update them, there has to be a better workflow around that. Because, see, unlike kind of application deployments with Kubernetes and creating YAML, sometimes if you make a little mistake with the deployment, you can be, of course, you can rerun it. You can update the Docker image for a new version. And it's not like always there will be a downtime, but I think you can easily revert, or you can easily see what the impact is. Sometimes with network policies, a little misconfiguration can cause, it can take a whole network down, can take the whole application or set of applications down. So it's really critical to understand the impact of those policies before you apply those changes. So we, with Calco Enterprise, you have a mechanism to, we help guide you into the creation process. You have a GUI behind it if you're getting started. We can actually, there's a way to auto-generate recommendation policies based on the traffic flows of existing applications. You can stage those policies so they're not being enforced, but you're still collecting the metrics around them. You can identify by previewing on the flow veg. You can review how they're impacting current data flows or current traffic flows. You can see, then you can enforce them and make some changes along the way. So just to kind of recap, you have the end-to-end visibility with those advanced flow logs. You have the Kubernetes context-rich flow logs, kind of metadata on it so they make sense. And you have a network policy workflow to help you and guide you as you start building those policies. So let's do a quick demo. I know we're just doing a time check. Maybe we can spend 10-15 minutes on a demo, and happy to answer any questions. I don't see anything yet. Might not be able to see anything yet until I stop screen sharing, but happy to answer any questions you have along the way. So for the demo scenario here, we're going to be, we have this application, just a sample microservice-based application, 4 services, front end, microservice 1, 2, and back end. The first thing we're going to do is just kind of understand what policies we can apply and how we can define so that the front end service can only talk to the microservices applications, and those microservice applications can talk to the back end. Let's not overcomplicate it with specifying specific ports, but at least we can create a typical enterprise segmentation where you have a DMZ, a trusted and restricted zones, and using those and anything in those zones using labels can talk to each other. So in this case, the trusted zone can talk to each other, and then but the front end zone can only talk to the trusted zone. It cannot talk to the restricted zone. And the same thing with the trusted zone can talk to the restricted zone, but the front end zone cannot talk to the back end zone, and so forth. And in that direction that I'm specifying here. So once we define those policies, I'm going to show you how they're displayed, how you can manage the lifecycle of those policies, and also get kind of into visibility into those policies and the traffic of this application. So let's just switch over. I have here a Kubernetes cluster running on GKE. This is the dashboard for Calco Enterprise that's running. Calco Enterprise runs as a native Kubernetes deployment. We have, at the high level, you have a set of, displays, histograms to show you what's going on in your cluster, how many endpoints you have, and so forth. Out of the box, this is my display. There's a couple of policies that have already been created, and you can see here there's definitely multiple tiers. If you as a user application owner, everything that you create, if it's not specified in a specific tier, it will go into the default tier. So that way, as a security team, you can specify higher policies that take precedence over, the default tier here. If you look at kind of endpoints, there's kind of a good display of all the endpoints here being the pods, full visibility into the pod IP, where it's running, how it's configured, what policies apply to it, and so forth. I have a couple of nodes here that are running in GKE. I'm going to show you kind of the flow visualizer real quick. So this is the flow visualizer. The outermost layer is the namespace. The middle layer is the service and the pod. And you can see here on the right-hand side, if I hover right away, I can see that this is, for example, microservice 2 talking to the Twilio API, and it's allowed. I can look at it by status as well. So if I see all green, that means all those interactions or flows have been, are allowed. I'm not seeing anything red here. So, and you can see here there's a bunch of other options that we have. We have an extensive set of features and functionalities. But going back to our demo scenario, if I take a look back into, hopefully you guys can see my screen. I'm connected to my cluster here. If I do my GKE, you can see here that I have a couple of pods. This is the application pods that are running. And they're running just fine. And one thing we want to look at is if we go back to the policies, how we define the 3 policies for this 3 segment: DMZ, trusted, and restricted. And you can see them here. One thing you'll notice is there's a staged tag to each of those. So one resource type in Calco is the staged network policy. So it's actually its own object type where when you create a policy, you can put it in staged mode, and therefore you can make some adjustment to it without impacting the traffic, collect the data, and based on that, enforce it. So let's take a look at, for example, the DMZ actual enforced policy. As I mentioned earlier, there's an easy way to kind of see what's going on here. You can see the name, where it's scoped. So it's applied to the zone equals DMZ. So any pod or deployments with that label is going to be included in this policy. It's going to be allowing certain traffic to certain destinations. From an egress side, you can see here that we're allowing this traffic to go to the trusted zone. So if you go back to our diagram here, we want to make sure that DMZ can talk in the egress direction to the trusted zone, but not the other way around. So you can see here that on the ingress side, we're not allowing anything coming from the trusted zone. So you have that level of granularity, and you can see that. And also, if you want to, you can create it here in the GUI, and you can actually have the default DMZ run here and have it kind of opened here for us. So this is the stage network. This is restricted. This is the DMZ policy you can see here. So this is exactly what I was looking at in the GUI, but this is in YAML format. So it's easy to kind of create things in GUI if you're getting started, and adapt and change as you move forward. So let's take a look at another policy here, which is kind of the restricted policy. And we want to make sure that, based on our understanding here, the restricted should only accept traffic from the trusted, and that's it. So you can see here that in the egress direction, in the ingress direction, it's only coming from, it's allowing it from trusted and only from restricted from itself. So it's not allowing it from the front end. And in this case, seems like I'm okay with sending it to any protocol, anything leaving those pods. So that's another example where it's more granular how you can actually segment your application and use kind of this workflow into and visualize what's what the network policy is doing and how it's set up. Let's say I want to make some changes here. Let's take another example here, this Twilio integration. So the Twilio integration is basically allowing this tier, the trusted tier, to talk to the Twilio. It's allowing the trusted tier to talk to the Twilio API. So if you take a look at the Twilio policy, if I make any changes, like let's say I by mistake, I remove this. I removed this egress policy rule that actually allowed us to talk to Twilio. Now, if I by mistake did that, I can preview it and preview the change here. And assuming I have network traffic that was going to Twilio, which I did, you can see here that it's whatever is blinking red means that if we apply those changes that I made to this policy, remember right now I have not applied them, I'm just reviewing them. If I apply those changes, this specific traffic is going to be impacted. So if we hover over it, you can see here on the right-hand side, the microservice 2 is talking to the Twilio API is going to be blocked. And you can see here that technically 2 right arrows, the first one being red, the second one being white on the right-hand side here. Oops, I can't do both. You can see here, that means that it was blocked at the source. So remember here, the policies within Kubernetes are blocked in the ingress or egress direction at this, at the pod itself. So it depends how you apply the policy or how you create it. This is how it's going to be blocked. So if I didn't know that this impact, how this is going to impact my application, and just applied the policy, I would have, basically I would have impacted and kind of took the application down if it relies on the Twilio API to communicate. Even though this pod could be sitting right next to a pod that's not supposed to be talking to the Twilio API, but because the policies are applied per pod, I get that fine-grained policy enforcement there for me. So that's another example where Calco and Thread can really help you with pre-detecting and kind of working on network policies on GKE. So let's kind of move out of that. So let's see if this is kind of the steady state or kind of the what we defined as what we want to see happening. That's why we're seeing that everything is looking good. All the, we're seeing a lot of traffic. Nothing, we're not seeing any traffic that is not, not part of the normal state that we expect for the application to see. If we go ahead and deploy a rogue pod, what the rogue pod is going to do is trying to do some interesting, kind of do like an nmap, or kind of try to connect to every pod in this namespace and do some kind of malicious connections to them. So because this kind of does not fall under our segmentation, we're not expecting this type of traffic based on the policies that we created. We can see, and it's not coming from those 3 tiers. Of course, there has to be some additional mapping of you have to kind of use RBAC to make sure that you have strict labeling and kind of understanding of the labeling taxonomy for your application. But that's kind of like a given thing when it comes to Kubernetes. But you can, if you go back here, we can see that there is you can see that there's denied packets right away. We're seeing that, so the policies are taking effect here. You can visualize that, you can understand that, we can see what's going on. If you have deployed this GKE with network policy enabled, yes, this probably will be happening the same way. That means that you can block certain traffic that's unwanted, but you wouldn't know when that happens. You don't have that level of visibility. So that's another huge advantage that we have with Calco running on GKE. So if we go back to the flow viz, you can see here, hopefully, there's you see the flashing lights here on the left-hand side. There's already some traffic that is being blocked. And if you hover over it, you can see here that there's Rogue that's trying to connect to microservice 1, and it's being blocked. And technically, it's being blocked by both the source, at source is being blocked, and at destinations also can be blocked, right? So, but the traffic never left the source, right? But that means that the policy is even if it did, it's blocking it in the ingress direction in microservice 1. So that's a multi-layer approach to defining and enforcing policies here for your workloads. So we're not expecting you to kind of sit and watch this dashboard. We have actually alerting configuration that you can actually use Prometheus Alert Manager. I don't have anything set up right now, but you can set it up so that it integrates with your Slack or any, with PagerDuty or any mechanism that you want to receive any kind of alerts around policies being blocking traffic, or there's some malicious activity that's going on. We have complete integration to help you with that. So with that was kind of quick, highlight of a couple of features and functionalities around network policies, how to create them, how to apply them, the value that you get both from a Calco perspective as well as Calco Enterprise perspective. So let's go back here. So that was kind of pretty much it around the demo. If you have never kind of worked on or played with Calco Enterprise, feel free to head to tigera.io/trial. You can get this full setup that you've seen on GKE, so you can get familiar with it. It's free. You can get it working. You just submit a request here, and you'll get that full setup for you, and you can play around and gain some knowledge and go through some labs if you want to. With that, if there's I would love to kind of take any questions right now, but hopefully you kind of saw the value starting off. We talked about network policies, what their value is, how you can run them on GKE, the different configuration that we talked about, but also we kind of touched for the most part on Calco Enterprise and some of the advanced functionalities, the visualization, advanced flow logs that you get that you wouldn't get out of the box. And we saw the value to that, of that to you. So I'm going to stop sharing right now, but happy to take any questions.